Hi, welcome to Stretching and Shrinking Lesson 4.2. Open up your notebook to your classwork. We're going to begin by looking at the answers to yesterday's classwork. We did problem 4.1a. Here are the solutions. On the right, you'll see the questions, and on the left are the answers. Pause the video so that you can take a minute to look at your work. On to questions B and C. Again, the answers are on the right. The work is on the left. The questions are on the left. Pause the video so you have a minute to look at your answers from yesterday. When you have finished checking over your classwork from yesterday, you can go ahead and turn to your ACE. Again, always go ahead and pause the video if you need time before, if I'm going too quickly or you need to look at something different, you can pause and then restart. Last night you had homework problem 1 was your first problem. I'm waiting for my smart slide to go forward 1. That's not a good sign, is it? There we go. Problem 1 was asking you to find all the similar parallelograms. Rectangle A and B were similar, with a ratio of 2 to 4 on their sides and for A and 3 to 6 for B. Parallelogram D and F were similar. For each pair, for B, each pair find the ratio of adjacent sides. For A it was 2 to 4, I mentioned that already, and B was 3 to 6. Both of those are equal to 0.5. For D it was 2.75 to 3.5. F was 5.5 to 7, and those are both equal to approximately 0.786. So therefore, if the ratios are equivalent, the parallelograms or the rectangles were similar. For each pair, find the scale factor. So the scale factor from A to B was 1.5. The scale factor from D to F was 2. How do those compare with the ratios? They are different than the ratios. The scale factor compares one length to another length or width to width, and the ratio compares adjacent sides. So a length and a width on one shape to the length and the width on the other shape. Problem 2 told you that A and B were similar. Oh, I'm sorry, it asked you to find the triangles that were similar. So A and B are similar and C and D are similar. Find the ratio of the two sides in one to the ratio of the other. A was 3 to 4 and B was 1.5 to 2, which are both equal to 0.75. C, the ratio was 3 to 5, D, the ratio was 1.5 to 2.5, and those are both equal to 0.6. Again, the same question for C, what is the scale factor and how is it different than the ratio? The scale factor from A to B was half, and the scale factor from C to D was also half. Both of those are different than the ratios. Again, the ratio compares two sides on one figure to the same two sides on a different figure, and the scale factor compares one length to the next length or one width to the next width. On question 3 and 4, it asked you to draw your own rectangles. All of those would vary depending on what you drew. And the point of this was in 4C, what can you say about ratios of the length and width for all three? All of the ratios should be equivalent, which means that those are similar rectangles. 15 through 20 asked you to say equivalent or not equivalent. 15 is not equivalent, 16 is not equivalent, 17 is not equivalent. I'm sorry, 17 is equivalent, 18 is equivalent, 19 is not equivalent, and 20 is equivalent. That was the end of your homework. Take a minute now to pause the video and fill in your table of contents. For today, we are doing lesson 4.2, and you should enter today's date. In lesson 4.2, we're going to talk about ratios within similar triangles. So yesterday we talked about rectangles, and all rectangles have 4 90-degree angles. So we can show that rectangles are similar by just comparing the side lengths. We know 2 ways to show that rectangles are similar. One is to show the scale factor between corresponding side lengths. So comparing a length to a length and a width to a width. The second way that we learned yesterday was showing that ratios with corresponding sides within each shape are equal. So length to width in one rectangle is equal to length and width, the ratio in the next rectangle. Now, we can only do that for rectangles and squares where everything is, we already know by definition they have equal angles. Comparing side lengths of a non-rectangular parallelogram or a triangle is not enough. In this problem, we use angle measures and side length ratios because what we know about similar figures is that they have all equal angles, so we need to prove that. So today you're going to complete lesson 4.2. We have questions A and B. Question A wants you to find the triangles that are similar to each other. Explain how you use the explain how you use the angles and the sides to identify similar triangles. So don't forget that sometimes to confuse you, they will rotate a triangle. You need to look carefully at the shapes to see what is similar. Then for question B, within each triangle, so you'll list this information for all 4 triangles. Within each triangle, find the ratio of shortest to longest and the ratio of middle to side. Shortest to middle. So if I were doing this, I would look and I would write down, see if my pen will start working here. This is not working for me, so I would just go ahead and put down that list triangle A and then put all of the work for that. Do short to long and short to middle, then triangle B, short to long and short to middle. B2 asks how do the ratios of side lengths compare for the similar. Think about what we just talked about. How should the ratios compare if the triangles are similar? And then how should the ratios for B3, how should the ratios of side lengths compare for triangles that are not similar? So make sure that you're completing all of this work. There's my pen. Completing this work in your notebook. Make sure that you're working hard, and if you need to compare answers with a friend when you're done, you can. Tomorrow's lesson will also be a video, so you can go ahead and we'll check that right away in the beginning of the video, just like we did today. And at the end of this, I will show you your homework. It is problem 2 and 27. If you get finished with the classwork, you can do this during class time. If you complete all of the work, make sure you're working on something else productive or reading quietly. I appreciate you guys working in the afternoon on this, and I hope that it all makes sense.